Hi, my name is Laura, and this is my final delivery of my key activity. These are my results from the experimental analysis. I used tracker to get the angle, the maximum height, the time, and the range. These two launchers are the one with maximum height and the one with maximum range. The launch number 1 had a greater height because the angle was bigger, and I put some diagrams to demonstrate that with a bigger angle we have a greater height, and in the other case the height is lower. The launch 2 had a longer range because the angle was closer to zero, causing more tension in the rubber band and increasing the velocity. Based on the range, the time, and the maximum height, I obtained the angles that are really different from before. And now I have the velocity that are really similar from each other. Here is my procedure for the launch 1. The first thing that I did was to get the y component of my initial velocity. For this, I used this formula that is pf squared is equal to v0y squared plus 2gh. The next thing that I did was only to substitute the values, and then I obtained the y component of my initial velocity. The second thing that I did was to get the initial velocity, but now on the x component. For this, it is really simple because we only have to divide the range by the time. And the last thing was to get the angle, and for this I use a trigonometric function that is tangent. I use it because I had already the initial velocity on y and the initial velocity on x, and I got the angle. And finally what I did was to get the initial velocity, that I only subtract the v of the formula of the x component initial velocity. For getting the data from the launch tree, I use the same procedure as before. The only thing that changes are the values. The main difference between mathematical calculations and experimental calculations with the tracker were that the angle was really different, and it could be because of many factors, including air resistance, the tension of the rubber band, the decimals that we include in our calculations, and maybe others. I learned a lot of things about this activity. The first thing is that I use my analytical thinking, mostly in the calculations. That is really important because we are working with the real world, and also I use the scientific method analysis. I learned to use new platforms such as tracker, and I use my coordination for the tracker and the catapult. We can use the projectile motion theory in many other things in the real life. For example, in sports, we can use it to calculate the trajectory of the balls in football, tennis, basketball, etc. The other thing that I wanted to talk is about the rockets, because even though we see projectile motion in a very simplified way, they use it in a certain way to calculate the trajectory of the rockets. And the last thing that is not really peaceful, but the snipers use projectile motion, or at least the theory, to calculate the trajectory of the bullets. My final reflection about this project is that I learned a lot of things. For example, I learned how to calculate stuff in the real world, I learned how to use new platforms, and I learned a lot of other applications for projectile motion in the real life.